Hi, welcome to 5-Minute Calculus on EVT, or as we like to say, the Extreme Value Theorem. Basically what the Extreme Value Theorem does is it finds for us the absolute max and mins of a graph, using calculus, of course. Now, if I'm looking at a picture, I can easily tell where my absolute max and mins occur. There's my max, and down at the bottom is my min. But a lot of times we can't look at a graph, or we're too lazy to do a graph. So we can use calculus to do this. Now first we're going to need a few things to find the extreme values. So the first thing we're going to need is the derivative. So step one, you need a derivative. You need the derivative, dy, dx, f prime of x, whatever you want to call it. Step two, we're going to need endpoints. Now, what's the difference? Well, the derivative will tell me where the slope is going to be 0. But the derivative cannot exist at endpoints, so we need to check the endpoints as well. Step 3, we're going to need something that we call the candidates test. And once we have all three of those, we can find where the absolute max and mins occur. So let's take a look at an example here. Let's say we have the function f of x equals 5 minus x squared, a simple parabola. And we're going to be on some domain, let's say from -3 to 1. And I want to find what's the highest point on this parabola. Now most of you already know it's going to be at the vertex in this case. But let's say we didn't know that. So the first thing we're going to do is we're going to take the derivative. We take the derivative and we get -2x. Now, the derivative is used to find critical numbers. So, we use this derivative to find what we call critical numbers. Now, as we've discussed in class already, a critical number is 1, where the derivative equals 0, or 2, where does the derivative not exist? So, since this is my derivative here, -2x, it's pretty easy to find out where it equals 0. -2x equals 0, x equals 0. Is there any place where this does not exist? Now, we're not talking about endpoints here. Derivative can't even try to exist at an endpoint. That goes against my definition of a derivative. When we talk about does not exist, we're really looking at what we call a vertical tangent. That's a vertical tangent. In other words, where does the derivative undefined? And in this case, nowhere. So it does not exist. So after you get your critical numbers, so we get one critical number here, it's x equals 0. Next we have to get the endpoints. And they gave us those. That's that -3 and 1. So I got my endpoints, I got my critical number, and now we do the most important part. What we call, so step 1, step 2. Now the third step, we have to use what's called the candidates test. And it is so easy, but most students tend to forget about this. They lose a lot of points. Mr. Werner gets angry. Angry face. This makes me mad when students forget about this. Why? Why? Okay, so the candidates test, very simple. It's a T-chart. You did this back in Algebra 1. I plug in my numbers. My critical number, x equals 0. I use my endpoints. -3, 1. My endpoints. Okay? And I plug them into the original function. My original function, which is for us 5 minus x squared. And I just plug them in. So if I plug in 0 here, I get 5. If I plug -3 here, I get 5 minus 9, or -4. Plug in 1, 5 minus 1, which is +4. And I compare. Which is the biggest one? The 5, which is the smallest, the -4. And therefore my absolute max, 0, 5, and my absolute minimum occurs at -3, -4. And now the reason why. By Menon. No, by candidates test. And there's your answer. It's lengthy, but look how I grade this. Look how the AP grades this. Took a derivative, 1. Find your critical numbers and your endpoints, 1, possibly 2 depending. Get your candidates test up, ready? Checking these values. 1. Getting your answer with the reason. 1 or 2 points. This is a lot of points on the AP. This can get you some major points. So show your steps. Show your work, okay? Alright, will this work for harder ones? Absolutely. So let's take a look at one more here, okay? One more example. Let's say we want to find the critical for the function f of x equals 2x over x squared plus 1. And I want to find this one. Well, step 1, we got to get the critical numbers. So step 1, get your critical numbers. So to get my critical numbers, I have to take the derivative. F prime of x, low, d high minus high, d low, all over the bottom squared. That's our derivative. Ugly. Simplify the top. I get 2x squared minus 4x squared, so a negative 2x squared plus 2 over x squared plus 1 squared. There's our derivative. Now, we're not done with the critical numbers yet, so we have to find out where does the derivative equal 0. Well, that's the top half. Negative 2x squared plus 2 equals 0. X squared equals 1. X equals plus or minus 1. Very easy to do. Where does the derivative not exist? Now here's our problem. This is where it does not exist. The one thing you can't divide by? 0. So I set the whole bottom equal to 0. Try solving that one. And we can't. So nowhere will this not exist. Now the one thing I did forget, we do have a domain restriction from negative 2 to 2. Okay, so we do have a domain restriction right there. So we got our critical numbers, just 1 and negative 1. Nowhere does it not exist. Then we go to step 2. Ready? Endpoints. Easy breezy. Negative 2 and 2. There's my endpoints. And now step 3, the most important part, your candidate's test. This is the most important part right here, because this is going to give us our answers. There's many ways you can do this. Many ways. But this is the way I like. This is the way the AP likes to see it. They like to see charts. Okay? Get your critical numbers on there. Negative, positive 1, negative 1. Get your endpoints on there. Negative 2 and 2. So, remember, critical number is where the slope is 0 or undefined. So we know that could be a maximum right there from another video. Okay, so if I plug in these values now, I plug them into the original function. That was this 2x over x squared plus 1. I plug it in. I get 2 over 2, which is 1. Plug in negative. I get negative 2 over 2, so I get negative 1. If I plug in negative 2 up here, I get negative 4 over, plug in, that's 5. If I plug in 2, I get positive 4 over 5. And I ask, where is my absolute maximum and where's my absolute minimum? Well, my absolute maximum is at the largest value. Right here, there's my max. So it's at the point 1, 1. Where's my absolute minimum? It's at the lowest point. Here, negative 1, negative 1. And why? By the candidate's test. This is starting to help us be able to determine what's happening to a function without actually having to see it. Okay, so on another video, I'm going to talk more about the difference between critical numbers and how they work for us. Okay, so take a look at that if you need to.